Hello everyone, now we will discuss on the topic industrial pollution control in grossly polluting industries part 4, and in this class we will focus on the pollution control in petroleum refinery and petrochemicals industry. The contents are general description, process and flow sheet for petroleum refinery, source of wastewater streams, treatment method and ETP flow sheet, ETP inlet and outlet quality, sludge management in refinery, air and noise pollution in refinery, process and flow sheet for petrochemicals industry, sources of wastewater streams and treatment method, effluent and emission standards for petrochemical industry. So, in the petroleum refinery we know that crude oil is converted into different petroleum products like say LPG, kerosene, diesel, petrol, etc. And crude petroleum is transported to oil fields, from the oil fields to the refinery, and then desalting takes place, and then atmospheric distillation takes place, and we get different products and the bottom products also we get, and then the bottom product is called the atmospheric residue. Atmospheric residue is processed in a vacuum distillation column and some liquid is recovered, and the remaining part comes as the bottom product, which is called vacuum residue. So, these are the basic operation, that is desalting, then atmospheric distillation, vacuum distillation, but this is not sufficient. There are many other conversion methods which are applied in refinery complex to meet the market demand of different products, petroleum products. And in petrochemical plant, some petroleum products are processed to produce different useful chemicals, and petrochemicals are extremely versatile and are used in everything from fuel to manufacturing. Different types of compounds are produced from the petrochemicals. Now, we will see the process flow sheet for petroleum refinery. So, overall refinery process and conversion of intermediate products. So, here we are having the crude oil. So, it is after desalting it is coming to atmospheric distillation. So, this gas which is getting out, then we are getting the LPG here, and then next lighter product is your light naphtha. After gas, then it is light naphtha, the next heavier is your after gas, next heavier is your light naphtha, after light naphtha heavy naphtha, then jet fuel, then diesel, okay, then atmospheric gas oil, and which is coming here as atmospheric bottom or atmospheric residue. It is coming to vacuum distillation, where vacuum is created, and so and temperature is also more than this atmospheric distillation. So, here the more complex molecules are broken down and the lighter vacuum gas oil and heavy vacuum gas oil are produced in vapor form and then condensed, and it is collected, and the bottom part we get the vacuum residue, and then here this vacuum residue is further processed to extract more liquid from it through delayed coker or through deasphalting process. Okay. So, this is the major operations which are involved in the petroleum refinery. Apart from this, we see many intermediate operations are there, like light naphtha to hydrotreater, then isomerization, then it is coming to the gasoline blend, and then it is coming gasoline pool, and then heavy naphtha again hydrotreater, then catalytic reformer, again it is giving us gasoline. So, here we are getting jet fuel. So, Maddox treatment, it is jet fuel and or kerosene. Here we also get the petroleum part and this gasoline, direct gasoline that is called, and diesel oil also we can get as a more heavier part, and here you know that hydrogenation hydrotreater. So, we can diesel oil we are getting here with improved quality, and atmospheric gas oil and then light vacuum gas oil then are going for FCC feed, and then cracking takes place, hydrocrackers, and then FCC fluid catalytic cracking, then it is going there alkylation, and ultimately we are getting the gasoline. And heavy vacuum, it is also going to the hydrocracker and hydrocracked gasoline. So, these are the different network of processes we can say. So, which are responsible to get more gasoline. So, when the market has more gasoline demand, so these are more gasoline or blend. So, when more demand of gasoline, that can be made by this. So, this is the overall process, and in this case we see here natural gas steam, it is hydrogen synthesis can takes place by this the vacuum residue also, and here in this case sour water, the steam tripper, this is one important, that is stripped water, the steam and sour water we are sending here. So, sour water means there sulphur will be there and ammonia will be there. So, those will be removed off by the stripping of steam. So, then we are getting the stripped water. So, this is one part of wastewater treatment we will discuss in the refinery, wastewater treatment in the refinery we will discuss. So, this is the overall process flow sheet. Now, in each and every step there will be the chance of the production of some wastewater, or there is a chance of the production of gas streams, that is the emission of gases due to leaks or any other reason. And if we see the different streams of wastewater generated in this refinery, those can be classified as process oily effluents or spent caustic, regeneration effluents and sanitary waste. So, what is process oily effluents? For different processes we may use some water, and that wastewater can be generated which will be containing the oil, and spent caustic basically is produced in the sweetening process, Marox process, and where scrubbing of the gases is there with the use of alkali. So, that is spent caustic we can use, and regeneration effluents means we can, when we regenerate the catalyst, then also there are some effluents are generated. So, those are the regeneration effluents, and catalyst is widely used in different processes in the refinery. So, regeneration is also widely used, and wastewater is also generated through this regeneration, and the sanitary which is coming from the office etc. So, you see these different waste streams are having different composition, like say process oily effluents will having oil, BOD, COD, TSS, phenol, sulphides, and spent caustic will have sulphide, phenols, BOD, COD and oil, and regeneration effluent sulphides, BOD, COD, and sanitary waste will be having BOD and TSS. So, we see here there is no that very special chemicals which needs to be separated except the phenols and some oil also. So, the treatment method and ETP flow sheet we will see for this. So, one important aspect was that stripping of the sour water. So, here in some processes SO2 is used. So, in that case SO2 is also available in the water. So, that SO2 has to be removed from the water, and then the water will be the some stripped water. So, stripping of sour water is one important part of the ETP flow sheet, and then segregated collection treatment of different effluent streams. As you see that different streams are generated having different compositions with different compositions with different concentrations as well. So, the segregated collection and treatment of different effluent can be used, and state of art wastewater treatment plant includes TPI, that is tilted plate interceptor, that is this is used for the removal of oils, and DAF, the dissolved air flotation to break the emulsion, oil water emulsion, and this is used for that purpose, and plastic media to biotower to improve the performance of the biological reactors and the processes, and centrifuges for the dewatering purpose, guard pond and recycle facilities and fountains. So, these are also used to maintain the wastewater, treated wastewater, and polishing pond for treated effluent, and separate sewage treatment plant for township. So, normally the refinery plants is very big in size and already it has some township. So, that sewage should have a separate sewage treatment plant, and total use of treated effluent and treated sewage is necessary. So, ZLD concept is being implemented gradually from grossly polluting industries. So, that complete recycling of waste stream is another aspect which industry should consider seriously nowadays. And main constraints and treatment philosophy for this refinery wastewater, if you consider, then because you see here we have oil separation, suspended solid separation, phenol separation, sulphide separations and organic matter separations. So, these are the basic need for the treatment of wastewater of the refinery. And then how we will do the treatment for free and emulsified oil. So, free oil is removed by TPI. We have already seen, we have already shown that some belt conveyor are okay. So, free oil is removed in TPI and free efficiency, the efficiency is directly proportional to the unit surface area, and emulsified oil is removed by dissolved air flotation unit. And treatment for sulphide. So, sulphide treatment, the sulphide may be present as Na2S in some water stream. So, in that case if we provide H2O2, so that Na2S can be converted to Na2SO4. We have discussed that H2O2 as a oxidizing agent and advanced oxidation process we can say. So, Na2OH Na2SO4 is converted, and sodium sulphate which is produced here, that is dissolved in water and is not more harmful, but further this can be removed by adding calcium hydroxide. So, calcium sulphate will be produced and 2NaOH, and as already we have discussed in case of sugar industry, that this calcium sulphate can further be removed by using polyelectrolytes. So, minimum sludge is formed, that is our objective to produce the less sludge. And process description, if we consider, then we have section 1, section 2, section 3, section 4 and section 5. The section 1 deals with free oil removal, physical and chemical treatment for removal of sulphide and emulsified oil, and section 2 biological treatment, and then 3 is polishing treatment, that is tertiary treatment, and 4 is slope oil handling or sludge management system, and 5th section, that is chemical dosing system. It requires many chemicals and that can be properly managed. Here we see the wastewater treatment plant flow sheet or flow diagram. So, we have wastewater, then as mentioned, as discussed earlier, the bar screen, oil water separation receiving some after bar screen, it is coming here. So, the after bar screen the water is coming to oily water separation receiving pump, and then it is sent to bar screens, channel grid and your parcel flume, and then it is coming to TPI oil separator, and after TPI oil separator TPI transfer pump, and then it is equalization tank, and then equalization tank to flash mixing tank, and flash mixing tank to DAF dissolved air flotation, and then from this it is going to pH adjustment tank and then bio tower. So, up to this we are having primary treatment and it is secondary treatment, feed pump and then bio tower. Then again this bio tower conversion to ensure further degradation, okay, the aeration tank is also used, and then after that it is going to clarifier. So, sludge will be collected as secondary sludge and then filtrate is going to the filter feed pump that will go through the packed bed, that is sand filter and activated carbon filter, and then the guard pond. This guard pond, that is the store of for the storing of this treated water, and that will go for further tertiary treatment, which as having 3 compartment, that is filter backwash compartment. This water is used for the backwashing of these 2 filters. So, then chlorination. So, chlorination is not done here because this is recycled for that purpose, and then it is chlorinated and it is going to disposal compartment, and disposal as per the need, if needed then tertiary treatment is necessary for polishing as a polishing step, and then it is used for different application. Now, chemical dosing. So, chemicals dosing for preparation of following chemicals like alum for TSS and TDS, caustic to increase pH, H2SO4 to decrease pH, DOP and DWP, that is dewatering polyelectrolytes and deoiling polyelectrolytes to remove oil and separation, and chlorine for chlorination, DAP and urea certainly for the growth of the microorganisms for the secondary treatment, and hydrogen peroxide sulfide removal. So, these are the different chemicals which are used in the plant, and for sulfur removal calcium hydroxide can also be used, like say sugar industry plant which we have discussed. Then here we will see how the treated water can be reused. So, TTP, that is tertiary treatment plant for making DM water. So, this water after going through the tertiary treatment plant, it will be sent to the DM water plant, and then make up to PCT, that PCT is your process cooling tower, or fire water makeup, or TTP rejection to coke yard. So, after TTP we will be getting the concentrate, that is a RO reject. So, that will go to coke yard, and blow down, that is from in the CPP, that is captive power plant, and PCT blow down will go to tertiary treatment plant, and then stripped shore tower, that is stripped shore water to desalter as wash water. So, these are the two applications of the stripped shore water, and storm water to green belt. So, these are the different reuse applications of the effluent, and the final quality of effluent to meet minimum standard. So, that is your pH 6 to 8.5, oil and grease 10 ppm, TSS 20 ppm, BOD 15 ppm, phenols 1 ppm and sulphide 0.5 ppm. Now, we will see the sludge disposal. So, both secondary and primary sludge are generated. So, sludge thickeners and centrifuge are used for this purpose. So, sludge sump to thickener to thicken sludge sump, then pump, then centrifuge. This is the sequence of operation, and it the concentrate to oil water separator, and cake is formed, that is sent to the secure landfill. And air pollution in case of refinery, if we consider, then desulfurization of fuel gas, installation of sulphur recovery unit, use of low NOx burners, use of low sulphur fuel, high efficiency heaters with low excess air, and tall stacks for dispersion of exhaust gases. So, already these are discussed in our earlier classes also. On the basis of these concepts, the design of different units, air pollution control units can be decided and installed. Some other measures for air pollution are floating roof tanks for storage of hydrocarbons, it reduces the leakage, and use of mechanical seal for hydrocarbon pumps, inert gas purging in compressor seals and feed tanks, two stage cyclone separator in FCCU, intermediate storage of effluent in closed tanks. So, all these helps to reduce the air pollution including the leakages. Now, we will see the pollution control in petrochemical industries, and the first we will see the process and flow sheet for petrochemical plants. This slide shows us different raw materials used for the petrochemical plants and different unit processes used in it, and basic chemicals which are produced from these raw materials, and these basic chemicals are further reacted with some oxygen, hydrogen, chlorine mixed acids, and then through oxidation, nitration, chlorination, hydrogenation, dehydrogenation, polymerization, we can get different petrochemical products or different petrochemicals, like say plastics and resins, synthetic fibers, synthetic rubber, intermediate and miscellaneous compounds. So, we can get different types of compounds, like say for plastic and resins we can get UF, PF, MF, LLDP, HDP, PVC, polypropylene, polystyrene, etc., where MF is melamine formaldehyde and UF urea formaldehyde resin, PF phenol formaldehyde resin. And synthetic fibers include nylon 6, nylon 66, polyester, acrylic fibers, etc. And synthetic rubber, SBR, BR, NBR, chloroprene, isoprene. So, SBR is styrene butadiene rubber, BR butadiene rubber, NBR nitrile butadiene rubber. Similarly, in this case of intermediate and miscellaneous components, drugs, dyes, pesticides, explosives, etc. So, many different types of chemicals and petrochemicals we can get in these petrochemical plants. So, there will be different units, different types of operations, and from each unit and operation there will be a chance of pollution generation. Now, we will be seeing here. So, whatever may be the products, in most of the petrochemical plants the naphtha is considered as a basic raw material and which contains olefins and aromatics, and from these after naphtha cracking we get ethylene and propylene and butadiene. These are building blocks and these are olefin types of compounds, and aromatic compounds are also there, that is benzene and xylene. So, these are the building blocks and these are converted to different intermediates and primary polymers and plasticizers, then maybe fibers or maybe chemicals. So, ethylene we can get EDC, PVC, EO, EG, where EO is your ethylene oxide, ethylene glycol, EDC is your ethylene dichloride and PVC polyvinyl chloride. So, there we can get PVC, polyethylene, LD, HD, low density, high density, or here we can get glycol ethers, ethanolamines, etc. Similarly, for propylene we can get isopropyl alcohol, acetone, and then propylene oxide, polyether, acrylonitrile, 2-ethyl hexanol. Again from this we can get, say from this we can get dyestuff and chemical intermediates. Here we can get polyurethane resins, here we can get directly polypropylene, and we can get acrylic fiber, and here we can get plasticizers. Similarly, from butadiene we can get ABS, we can get PBr, we can get SBr, where ABS use acrylonitrile butadiene and styrene, and PBr is your polybutadiene rubber. So, here we are getting rubber also, and from benzene and xylene we can get different intermediates. From benzene we can get cumene, phenol or phenol, and then cyclohexane, caprolactam, ethyl benzene, styrene or styrene, detergents, acrylate, maleic anhydride, and which are converted into the different products as mentioned here, that is pharmaceuticals, thermoset resins, nylon, polystyrene, detergents, okay, alkyl resins and polyesters. Similarly, for the from the xylene we can get phthalic anhydride, DMT, and then that is DMT is dimethyl terephthalate, and then plasticizers, and we can get polyester fiber. So, these are the different products we can get from naphtha. So, this is the petroleum product tree which are generated in the petroleum complex, petrochemical complex. Now, we will see the different source of emission generation, emission and wastewater generation. So, important sources are emissions from storage and handling, then process waste emissions, fugitive waste emission and secondary waste emissions. Certainly, the emission from storage and handling, the storage tank, trucks, railway and marine terminals are the sources of volatile organic carbon emission and oil spillage problems. Process waste emissions from reactors, distillation columns, purification equipment, fire heaters, condensers, reformers, crackers, filters, sulfur recovery unit, recovery and control equipment, stacks and vents, etc. So, here heaters, furnace, those are extensively used in this refinery and petrochemicals unit. Fugitive waste emission, there are two types of fugitive waste, that is low level leaks from process equipment and episodic fugitive emissions, where even an equipment failure results in a sudden large release, and this fugitive emission may occur from pumps, valves, flange, mechanical seal, relief valves, tanks, instrument connections, sample connections, open ended lines, etc. And secondary waste emissions from the wastewater treatment unit, cooling tower, boilers, process sewers, etc. Now, there are some technologies for pollution control for wastewater treatment. So, the shore water, how this can be treated? So, sour water results in different sections when steam and or water used in various processes pick up H2S and NH3, which is not properly treated, affect the wastewater treatment system. So, this is a sour water treatment plant. The sour water stripper either uses the direct application of stripping steam or a steam fired reboiler as a heat source. The sour water is often stored in crude tanks, thereby eliminating the need for special vapor recovery systems. So, here sour water it is coming and then it is going to the feed to the stripping section, and then gas of, so sulfur H2S gas is going out and ammonia is also going out, and then we have stripped water. So, that is used as the effluent. So, that is where we are able to remove the sulfur now by the stripping. Now, emission standards for furnace, boiler, heater and vaporizer, as you mentioned that there are large number of this type of equipment used in this petrochemical industry, and here NOx, SOx, CO, PM it is given for gas firing and liquid firing case, gas firing and liquid firing. So, different cases for the release of these pollutants for existing plant and for new plants and expansions. So, this is mg per normal meter cube, these are the limits it is given. So, you see that for new and expanded plants there is a significant changes in the standard values. So, that is why it is targeted to reduce the pollution as well, and in some cases we may have that phthalic anhydride, malic anhydride and terephthalic acid and dimethyl terephthalate. So, in that case norms for carbon monoxide shall be implemented, and emission standards for organic particulates like phthalic anhydride, malic anhydride and this. So, 50 existing limit and then new 25 and mass flow limit is 100. So, this one. Emission standards for process emissions, specific inorganic pollutants also it is given. This is emission standard for process emissions. So, like chlorine, HCl, so this is small HCl and then ammonia, H2S, phosgene, HCN. So, these are the different sources and this is the maximum emission limits, and this is the effluent standard for wastewater. So, pH is 6.5 to 8.5, BOD 5, 50 and mg per liter, COD 250 mg per liter, phenol 5 mg per liter, cyanide 2 mg per liter, fluoride 0.2 mg per liter, hexavalent chromium 15, and this is the standard of effluent, and this slide shows the minimum national standards for petrochemical industries, that is for effluent, that is wastewater. So, we have discussed different aspect of the pollution control of petroleum refinery and petrochemicals industry up to this in this class. Thank you very much for your patience.